Hello, Mrs. O'Donnell here. Today we are factoring special products, specifically looking at cases with GCF and where you can use grouping. So our goals for today are to develop procedural fluency factoring polynomials with GCF or polynomials with 4 terms. Again, if you are struggling at all, please come to my office hours. I am happy to help. All right, so if we recall factoring our quadratics, it says first convert the following from standard form to factored form. Okay, so we know that this is a special case and maybe you just have it memorized, but if you don't, come off to the side, make your box, and let's use this area model here, right? So we know we've got x squared, we've got a negative 81, and we know our diagonal is going to make 0x, right? X squared plus 0x minus 81 is this quadratic in standard form. Okay, so if I want to do some factoring here, x squared is nice and easy, that's x and x. And then 81, well, that's a perfect square. That's 9 times 9, except one of those has to be negative because you have to have a negative multiplied by a positive to make that negative. And if we check out what that does here inside of our square, or inside of our box, negative 9 times x is negative 9x. X times 9 is 9x. And if you combine those like terms, you get that 0x. So that worked out really lovely. All right, so our factored form would be x minus 9 times x plus 9. Remember, if you wrote it x plus 9 times x minus 9, you're just using the commutative property to rearrange those factors. It's still going to give you the same thing. So now that we're really comfortable with factoring just our basic polynomials, we want to take a look at polynomials where we have sort of this GCF or greatest common factor occurring. And what you might notice is hey, 9, 66, and 21, oof, those are big numbers for us to try and factor out. There's going to be a lot of factor pairs that go into factoring this polynomial. But you may also know that 9, 66, and 21, those all have a factor of 3. Those can all be divided nicely by the number 3. So if we do that, if we factor out that 3 first, we're really going to be looking at our factors for 3k squared plus 22k plus 7. And I have a feeling that that's going to factor out a lot nicer. So let's check it out, right? We're going to kind of set that, let's see here, I'll use pink. I'll use blue. We're going to set that 3 kind of off to the side here. I know my factors are going to come in, at the end when we have our final answer. So I can fill in my box. I've got my 3k squared. I know my 7 comes down here, and my diagonal is going to add to make that 22k. All right. And let's see, I can start doing some of my factoring. 3 is nice because it's a prime number. So I've got a 3k times a 1k. And same thing, 7 is prime. I just have to figure out which side the factors are going to go on. So I know I'm either going to have a 1 and a 7 like this, or I may have to sort of flip-flop them. So let's try it out. So k times 1, that's going to give us 1k. 3k times 7, well, that gives me 21k. And if I add those together, I get 22k. So it worked out. I got lucky. If it didn't work, I would have just flip-flopped. I would have put my 7 down here, my 1 up here, and tried that. All right, so I know I've got factors that are 3k plus 1 and k plus 7. Okay, and if I want to go ahead and solve for my zeros, I'm just going to take that and set it equal to 0. The nice thing when you're solving to find those zeros is that you really just need to look at the factors with the variables, right? 3 is never going to equal 0, right? That factor is just not ever going to be equal to 0. It's just the number 3. So here I set my other two factors equal to 0, and I can go ahead and solve them using my inverse operations, right? So subtract 1 from both sides of my equal sign. I've got 3k equals -1. Divide both sides by 3. So I have k equals -1/3. I can do the same thing over here. I'm going to get rid of that +7 by doing the opposite, or the inverse, which is -7. So k equals -7. So my zeros would be -1/3 and -7. Okay, so let's take another look at factoring with a GCF. Okay, so if you don't recognize that there's a GCF off the bat when you're factoring, you'll notice a couple of things. You'll notice as you're working through your box method that your numbers are just really big and you're having to do a lot of trial and error. You may also notice that you're able to factor it, but it won't necessarily be factored completely. You might find some factor pairs that work that could potentially be factored even further. All right, so that's why it's really important at the beginning. The best option you have is to factor out that GCF right off the bat. Okay, so if we look here, you might even at this point want to take a minute, pause the video, give this a try. See if you can factor out the GCF and then factor completely. All right, so hopefully you're noticing 15, 27, and 6. Those all have a common factor of 3. And I'm going to write that right below here. So if I factor out that 3, 15 divided by 3 leaves me with 5x squared. 27 divided by 3 leaves me with 9x. And 6 divided by 3 leaves me with 2. So I'm going to be factoring 5x squared minus 9x minus 2. All right, and I know that diagonal is going to add to make that 9x. Okay, and I can come off to the side here. I want to be very cautious. You want to be very cautious when you're factoring out a GCF that you don't lose that GCF in your final answer, right? So I like to make a note kind of off to the side, wherever it is I'm going to put that final answer, that factored form. Okay, so I don't lose that GCF. All right, so let's see here. 5 is, let's start factoring. 5 is a nice prime number, so I know I'm going to have a 1x and a 5x. And 2 is also a really nice prime number, so I know I'm going to have a 1 and a 2, and I'm going to have a negative in there somewhere. I'll put it with my 1. And let's see here. So now I'm going to check and see, did I actually arrange everything correctly? Are these my correct factors? So 5x times -1, well, that would give me a -5x. 1x times 2, that's going to give me a 2x. If I go ahead and add these, I've got -5x plus 2x. That gives me a -3x. So I didn't quite get to my -9. So that means I have to change something. Okay, so let's see here. That didn't work. I'm going to erase that. That means I have to change something about this, maybe this -1 and the 2. I don't think just changing the negative sign is going to be enough. What if I switch the sides that my factors are on? So I'm going to put down, let's see here. I'm going to put a -2 down here and a 1 up here. -2 times 1, that makes -2. -2 times 5x, that gives me -10x. Oops. Blue. Do it in blue. -10x. And 1x times 1, that gives me 1x. -10x and 1x gives me -9x. So, all right, the second time I did it, I managed to get all my factors put in the right spot. So now I've got 1x minus 2 times 5x plus 1. And again, if I want to solve for zeros, I'm just going to take the factor pairs that have variables and set them equal to 0 and solve using those inverse operations, right? X equals 2 over here and then minus 1. So I've got 5x equals -1 divide both sides by 5, so x equals negative 1/5. All right, and there's my factor pairs. All right, so hopefully now you're feeling pretty good about factoring out a GCF. So now let's look at a different kind of problem. In this problem, we want to do some factoring by what's called grouping. We have four different terms in this polynomial, right? So thankfully, I have 4 boxes. I'm going to just go ahead and fill in my terms. Now, one thing to pay attention to here is that our polynomial is written in standard form, right? So all of our exponents are descending. All right, so our polynomial is in standard form. I've got 4 boxes, four terms. Let's see if we can factor them. So 14s cubed and minus 7s squared, let's see here. If I'm thinking about things that are going to multiply into both of those, I see that those both are going to have a 2s squared, right? It's kind of like a little reverse Sudoku. So 2 multiplies into 14, so I'm doing that, pulling out that GCF. 2 times 7s gives me 14s cubed. 2s squared times, oh gosh. I did something wrong. I flipped it around, didn't I, guys? Help me out. All right, let's see here. Again, so 14 and 7, those both have a common factor of 7s squared. And then up here would be my 2s. And then same thing, I've got 7s squared times a negative 1 to give me that negative 7s squared. And then now, since I've got part of my little Sudoku, I've got 2s. I want to think, what's that going to multiply to make 20s? Probably 10. And then 10 times negative 1, well, that worked also. So that would mean that my factored form would be 7s squared plus 10 times 2s minus 1. 2s minus 1. And again, you know, sometimes when you're doing factoring by grouping, you have to check and see, is this factored completely? So I've got this 7s squared plus 10. That s squared possibly could factored out even further. 7 is a prime number, so that's a big indicator. Once you start seeing those prime numbers, that it's probably not going to factor down anymore. We could solve for our zeros by plugging back in, but at this step with a cubic, we're not going to talk about zeros just yet. Okay, we'll save that for Algebra 2. All right, so let's take another look, factoring by grouping. Again, we've got 4 terms, we've got 4 boxes. You can go ahead and fill those in. You want to make sure that you keep your polynomial in sort of that descending order. If you start to get it jumbled up, the factors might not present themselves as nicely. Okay, so we're factoring by grouping. And again, let's see here, 20j cubed, negative 10j squared. Well, I see that those both have a j squared, and they both have a 10, right? And let's see here, 10j squared, that would multiply by 2 to make 20j cubed. 10j squared, that's going to multiply by a negative 1 to make that negative 10j squared. And I've got 2 times j to make 2j, and j times negative 1. You guys see where I went wrong? There should be a j here, and down here should be a 1. And voila. Yep, that looks good. 2j times 1 makes 2j. 1 times negative 1 is negative 1. So my factored form would be, again, we're not going to do zeros because it's a cubic. My factored form would be 10j squared plus 1 times 2j minus 1. If you wanted to check your answers again, you were kind of self-checking as we go, but you could use the distributive property, distribute through, and